All right, so we got our four examples here for today. Okay, and our first one is going to be how many moles of calcium carbonate are in 125 grams? So they're asking us to calculate the number of moles, which is little n. Okay, we are looking for the molar mass of calcium carbonate. So that'll be 40.08, our 1 calcium, plus 12.01, our 1 carbon, plus our 3 oxygens. All right, so when we're putting that together, sorry, should have started that calculator before. So 40.08 plus 12.01 plus 48. Okay, so 100.09 is our molar mass for that. Grams per mole. Okay, and the other thing they tell me in the question is the mass is 125 grams. So I've got big M, I've got little m. I don't have to do anything to that formula. I just need to plug in the numbers and solve for n. Okay, so that'll be 125 divided by 100.09 should give me 1.25, yeah?
Yeah.
No. Okay, 1.25 moles. My final answer. Okay. Questions on number 1? All right, and question number 2, what's the mass of 2.7 moles of lithium phosphide? So we are looking for little m this time. They tell us N is 2.7 moles, and they tell us the material is lithium phosphide. So that'll be 6.94 times 3, my 3 lithiums, plus 30.97, right? Yeah. 97, okay, and there's only one of those. Okay, so 6.94 times 3 plus 30.97. So we're looking at 51.79 grams per mole. Okay. So I have to use the mole equation, n equals little m over big M, but I've got to solve for little m, which means I've got to move big M. I'm dividing by big M right now, so to move it, I do the opposite. What I do to one side, I do to the other, and now I've manipulated my formula for little m. So mass will equal 2.7 moles times 51.79 grams per mole. And we're looking at 139.83 grams. Okay, questions on the second one? Okay, how many people have done? Okay. So in number 3, we're going to have to use Avogadro's number. As soon as molecules or particles are mentioned, atoms are mentioned, okay, then we're going to need to use Avogadro's number, 6.02 times 10 to the 23. We're looking for the number of molecules. Okay, we're told that it is iron 3 oxide, so we're going to have 55.85. So 55.85 times 2, so that's our 2 irons, plus 16 times 3, our 3 oxygens, and that'll give us our molar mass. Okay, so 159.7. Okay, so now we've got our molar mass. The other thing they tell us is the actual mass, 230 grams. All right, what can I calculate with little m and big M? N. All right, I got to calculate the number of moles. Okay, so number of moles, little m over big M, 230 grams divided by 159.7 grams per mole. Okay, 1.44 moles. Okay, what's my next step? I have the number of moles and I have Avogadro's number.
You do like 1.44 times 6.02.
Exactly. I'm going to multiply the number of moles by the number of molecules in 1 mole. And that will tell me how many molecules I have. Okay, so I'm going to go molecules equals N times Avogadro's number, okay, which is 1.44 times 6.02 times 10 to the 23. Okay, remember we put that in brackets, 6.02, second E 23, close the brackets. And we're looking at 8.67 times 10 to the 23 molecules. Okay, questions on number 3? Okay, how many people have done 4? Okay, you guys are getting fast. How about I give you just a couple minutes, because I didn't see everybody's hands up, so I'm going to give everyone just a couple more minutes on number 4, and then we'll go through that. So on number 4, we're looking for the mass, so we're looking for little m. Okay, we're told the number of molecules. It's 5.42 times 10 to the 21. More or less than 1 mole? More or less? Less, yeah. Okay. I mean, 1 mole is 6.02 times 10 to the 23. This is times 10 to the 21, significantly less, okay, than 1 mole. All right, and the only reason I ask that is because sometimes when people figure out how many moles there are, they're thrown because they get a decimal. And they, ooh, that can't be right. Okay? It's absolutely right. Okay? We just have to look kind of logically at the numbers that we're given. Okay. The other thing we're told is the material, it's nickel 2 nitrate. Okay, so nickel is 58.69. And there's only 1. Okay, and then we've got 2 nitrogens. So 14.01 times 2. Okay, and we've got 6 oxygens. All right, so looking at 182.71 grams per mole. Okay, so if I'm going to get little m, I need n. Right? How do I get n with the number of molecules and this number? What do I do with those two numbers to get n? Exactly. Okay, so like Ethan said, we take our number of molecules and we divide by Avogadro's number. Okay, that will leave us with number of moles. Okay, so we'll take our 5.42 times 10 to the 21 divided by 6.02 times 10 to the 23. Okay. Whoops, I didn't get the slash in there. Okay, this is why I brought that up. A lot of people look at that number and they go, oh, I must have done something wrong. Okay, shouldn't get 0.009. Yes, you should. Okay, this is an incredibly small number, okay, because this number, 5.42E21, is way smaller, okay, several hundred times smaller, okay, than this number. So it's okay to get that decimal there. Okay, I'm going to keep all those decimals. I'm just not going to write them down. All right, so 0.009 moles. And now I can calculate the mass. I'm going to take n equals little m over big M. I'm going to manipulate by moving m to the other side and take my 0.009 and multiply it by 182.71 grams per mole. And we're looking at 1.64 grams. Okay, how important are the units again? Vary. If you don't have units on your answer, or you have the wrong units on your answer will be wrong. Okay, you can still get marks for your work, okay, but you won't get your mark for your answer without units. Okay, so incidentally, on the note of work, remember that this would be a 5-mark question. You would get a mark for your givens. Okay, you would get a mark for calculating your number of moles, you would get a mark for your algebra, a mark for plugging in for your math, and a mark for your answer. Okay, should you show your work? Yes. If you get the right answer and that's all you show, I still have to give you 5 marks. You're either a brilliant guesser and guessed that number out of all the possible numbers. Okay? Or you did the work and didn't show it and got it right and know what you're doing. Here's the problem. Some people think they're good enough to not show their work. And they make a silly mistake. Because they might actually be good enough they don't have to show all their work. But they make a silly mistake on their calculator. And they write 2.5 grams. And nothing else. What do they get? 0 out of 5. But could have got 4 out of 5 if they'd written their work, because they knew exactly what they were doing, they just touched the wrong button on their calculator. Okay, got to make sure you show your work. There's marks for every step. Okay, and I only kind of bring this up and harp on it a bit because I've had students in the past who have gotten burned on this. Okay, like I had an argument, semester-long argument with a kid. I don't need to show my work, Mr. Cooder. I don't need to show my work, Mr. Cooder. And he was smart. He was. Okay? He was doing a lot of it in his head, and good for him. The problem was when he got to the final exam, he didn't put his calculator back in degree mode after it was reset. And every trig calculation he did was wrong. And he wrote down the wrong answers with no work on much of the test. And instead of getting the 85 he should have got on his final exam, he got like 60 something. Okay? Not the mark he should have got. But when you don't show your work, all I know is your answer is wrong. I don't know how you arrived at it because you didn't show me. Okay? I can tell if you show all your work and you have the wrong answer, I can go, oh, that sucks. They pressed the wrong button on their calculator. Obviously, it's the only way they'd have written that number with all this work. Okay? And then I can still give you 4 out of 5. You lose a mark for being incompetent with your calculator, but that's not the end of the world. Okay? It's always important to show your work. All right, let's take about a 3-minute break, and then I'm going to put some other questions on the board that I want you to work on for this. Tomorrow, we're going to do our unit exam review. Okay? So I'll post the review package probably today at some point, and then I'll do a review tomorrow to prepare for the test. Okay, so these questions are in the digital workbook. Okay, this is page 13 of the digital workbook. Okay, and it starts out 8, 9, 10, and 11 are exactly like what we've been doing, right? Number 8 is asking you to calculate the number of moles. Okay, number 9 is asking you to calculate the mass. 10 is the number of atoms. Okay, so all stuff that we've done. But I don't want you to do all of them. Okay, I want you to do for number 8 just D and E. Right. For number 9, just D and E. And for number 10, B and C for now. Okay. All right, so you guys can get going on that. Okay, I'll go through those if they're giving us trouble here.